units, and that's where, put my experience forward.
So today we do have some questions about already prepared for you. So, and one of the big questions in the building industry is how do we get into a circular economy? So, and my question for Marcel as a start is, so circular economy, what does it mean? Is it just a concept, or will this really change the future of the facade design? What do you think?
Yeah, thanks. Yeah, the circular economy or circularity in general is a big topic here in the Netherlands. Our government has claimed to fulfill the European emission goals by 2050, including all kinds of savings. But one of the aspects is also that we have no waste at 2050. Means we all have to think about how do we get rid of all the waste, and the building sector is in general a bad player in this game. 40 to 50%, according to which research sources you are reading, is responsible for the waste. So therefore, in architecture and on the building side, we create a lot of waste, not only on the building side, but also in the production. So therefore, circularity is an aspect in which you think about the entire loop of a material from its origin till its end. Means we have to think about not only about the lifetime of a product, for instance, an insulating glass unit, but we already have to think about what will happen in 20 years. It's the usual lifespan of an insulating glass unit. What will happen with these elements that we are able to bring them back into the loop, meaning recycling, reusing or repurposing all different heights or values of further use. And that is a huge challenge for everyone within this role of stakeholders, which makes it a very big challenge and a totally new aspect of thinking. So therefore, we see in the Netherlands, circularity is not only a trend, but it's really a driving force for the entire industry. Not only that clients and customers nowadays wanted to have a certain ratio percentage of circular products within, but they're also pushing that forward to the architects to include as many products as possible. And they for sure push this further to the industry. So we've been on the trade fair for facades in Utrecht 3 months ago, and almost every of the companies over there already had answers about circularity. Sometimes it's just that they already figured out how to take this material back, and they have been able to clarify the product documentation, that they know exactly, and also sharing what the products are made out of. But sometimes it's a big question. Nowadays, we can already assume that glass used in architecture will never be used in architecture again due to the coatings and the IGU corner details. It's most likely will end up in glass. Maybe it becomes clear glass for bottled glass, and it becomes wine bottles, and then maybe beer bottles, so degrading in the use of it.
I have two questions for that. Do you think this will increase the price and the second of a single product? And the second question is, I mean, there's this urban mining wording, which means you get the material out of used materials, or out, in this case, out of used facades. Do you think this is compulsory to get things out of that because the shrinking of the resources, or not?
A couple of aspects to that. We have been asked from the Dutch facade industry, the VMRG, that's the big umbrella corporation. They have started to think about circularity, and in this case, facades as a product. A couple of years ago, my colleague invented leasing facades in order to make sure that at the end of its lifetime, 20, 30 years, the facade profiles, aluminium, comes back to the manufacturers here in the Netherlands. Usually everything ends up on the Chinese market. The Chinese bought everything we trash here, and they, as an industry, wanted to make sure that they can get a grip on the material because of its high value. So therefore, this idea of facade as a leasing concept or as a service comes into place. We see also, on the other hand, that the companies who demolish buildings are nowadays more and more specialized in order to sort on the site already, because they have been contacted by urban mining companies or become urban mining companies in order to make sure to get the most out of it. Back then, you had to pay if you want to get rid of some waste. If you're nowadays able to sort it clearly and make sure you address what you have, you may be able to get money back from that. So therefore, there's already a change in that. And on the very last, there's also concepts that will start to go ahead for, let's assume there's a company, a local company that is specialized in rebuilding glazing units. So they come to your place, they take the insulating glass units out, they de-seal, they make a new ceilings, put new gas in, and then install it again for another 20 years. That is a new, totally new business concept. Usually you take them out, throw them away, install new ones, but there might be even more labor intensive, locally located companies that will start this as a service, kind of like a shoe repair guy. There's the one who sells the shoes, the bigger companies, and at a certain point, there is something wrong with your shoes and you go to a shoemaker who's able to repair it and makes it for another 5 years or something like that. Very interesting concepts, all in its baby shoes right now, but we see a certain trend and also the rise of new companies and business models.
Okay, so Hannes, can you add something to that, please?
Yeah, well, I'll agree with Marcel. There is this trend that we have to follow, and the pressure is increasing. I think there is a complexity with it, yeah, which was resolved in other industry. If you look at aluminium or metal, there is a clear recycling path. There is an industry for that which exists. With the glass, we don't have that. Certainly not that we keep the glass at that level of vision glazing. So we might downcycle, but that's not what we want to do. So if we want to keep it on that level, this recycling path is not established. So we need to think about the mining. How can we get it out of the building? And we need to think about, do we create an industry which hands it back to the industry with the metal, like there is a recycling industry and it gives it back to the metal industry?
Yeah.
Or do we go for another approach? I mean, this idea of renting out facade or leasing out facades, I personally really like the idea because we could resolve certain things with it. But I think there is a legal complexity in it. Who owns the material? What do we do if the one who leases the material doesn't pay his bill? Can we just take his building apart? So there are a lot of challenges, and I think the positive thing about this right now is everybody's looking for answers. Everybody tries to find a way. We don't have them right now. We don't have the one answer that we can say that's it, how we move forward. But the positive thing is everybody thinking, everybody makes little small trial projects to figure out what we can do in the future and how we can establish that.
Yeah, may I add one thing to that? I was talking to Vicona, or to one of the CEOs from Vicona, and what they did, they started a recycling. They bought a recycling company 3 years ago, and they refined the recycling process very much. So they really go into such a small whatever grinding what they do with the aluminum material. They get second used aluminum, which is at the same quality as premium mined aluminum out of the mine. So it seems to be there should be a really recycling process. It has to be worked on properly. I mean, with glass, it's a problem so far as we see, as Marcel just pointed out. What do we do with the coatings? How do we get rid of this stuff that we get really good glass out of it? Okay.
Well, if I can add to that, so the coatings we know how, or the glass industry knows how to handle coatings. The coatings are very small quantity, so we have to the individual subjects, we have answers. We just need to get this in a big concept where whole Europe, because it's not a thing of a company. We need to get an industry established or a system established where whole Europe can work with, and we can use glass from one company in another company. I think that's how we need to handle it. I don't think that this is a one company solution kind of.
Yeah, I agree. So at this point, I would like to introduce Jorma. Hello, Jorma, good to see you. Can you please get your microphone on? Yeah.
Okay. Can you hear me now?
Yeah, now we hear you. So I'd like to introduce co-host Jorma Vitkala. He's the father of the Glass Performance Day in Finland, and he's running with me this series with the webinars. So Jorma, we already had the first question, talked about the first question about circular economy. Now we are jumping into the second questions. Would you like to go on with the second question about new material and facade?
Basically what we was talking about, the insulating glass units, and Hannes, what I like to ask it from you is really this problem what we used to have it in here in Scandinavian countries, but I believe that you have the same in Germany also, is condensation in the surface number 1, basically in autumn time. Have you find out that one, the similarities what we have it in here in Scandinavian countries?
Yeah, it is an effect of not the new material, it's of high insulating units. So if we have triple glazed units with very low U values, and especially in autumn time, maybe in springtime when we have very low sky temperatures, and those glasses are exposed to these radiations of the sky, they cool down a lot, especially in autumn. The humidity in the air is relatively high, so the glass starts to create condensation on the outside, which didn't happen in the past because the insulating glass units haven't been as efficient, and there was enough heat coming out from the inside of the building, and the condensation that we can see now evaporated. So when we are creating new materials, we're facing new challenges. In that case, there is the option that we could heat the glass. Now we can talk about sustainability, and I presume heating the outside of a building is probably not the best way. There is coating options that we can use, low emissivity coatings, which can be exposed to the outer surface. That's what we can do. But it's really a physical limitation that we are facing. It's the same with the car windows. They face condensation, or they face that we have some ice film on it in the winter time. Yeah, we in the past it wasn't an issue, but now we need to face those new topics.
Marcel, would like to add something?
Yeah, I'm wondering how long during a day that this happened, because we have it also here. I am living in a big block, 100 users. 1910 we got recently refurbished. We got new windows and just double insulated glass standard, not that good, but we also made sure that we had introduced this phenomenon of condensation on the outside in the morning due to the fact that we are living alongside a river. And we have mentioned this as a quality sign because they are so well insulated that under specific circumstances, condensation happens. While the email didn't seem to reach all of them, everyone else who has seen the same effect and wasn't enlightened or explained in advance directly complained about condensation, and everyone who got it and got the information were very happy as a proof of a good insulated window. But the question is, in your case, for how long does it happens? Are you able to look outside for entire days or just an hour in the morning?
May I just
usually it happens in Scandinavian countries. We talk about at least up to noon, or even later. So it's a pretty frustrating anyway on that one. And nowadays they start to use it, let's say the hard coating in the surface number 1, which increase the temperature of the outside pane. And then this one, what Hannes, you explained, it doesn't happen that even that we have a cold or the black sky, which is about 20 degrees, whatever is it, what we call it, lower temperature, and
Yep.
it's radiating the heat from the glass. But that's an interesting anyway. The many cases, the good insulation give it some trouble anyway. But we need to see the positive things, but also the same things. What Hannes, perhaps you can explain a little bit more, is those mobile telephone signals, and now when we go to the 5G system, it's even coming worse.
Yeah, but I like to add something before, Marcel. You know, it is problematic if some private person who has got the window for the living room changed, the big window from the 60s, and then they cannot look out until the sun shines on it and gets all this humidity rid of. I mean, this is a bit of a tricky bit to sell, you know. You can say it's a big quality sign, but if you cannot look out the window, which is the core product, it's tricky. I mean, therefore we need some things. But yeah, so Hannes.
But it's also the question, how often does it occur? If you are not able to look out of your windows 365 days from 9 o'clock till 12, you have a problem. If it occurs every now and then, I would say it's negotiable. And if the people are aware of it, because it's building physics and you can't trick building physics, or if you have to pay more in order to get better coatings and whatsoever, in order to avoid that, that's another topic. So therefore, it's in principle, we have to be honest, and people doesn't want to pay more if they know what they are buying into. But if Jorma mentioned that till noon you can't look out of your window, and especially in an office building or whatsoever, that is of course a different problem.
Yeah. Okay. So let's get to the next question. Jorma was asking you about these coatings with the telephone increase. Yeah.
So yeah, that's another thing that occurred with developing insulated glass units. We have those silver coatings on top, which create the lower emissivity and therefore improve the U value. But what we have is a continuous metal surface, and it just doesn't allow for radio signals to pass through. So what happens nowadays is that very often there is a gap. Let's say the frame might be the gap, or another element of the building that might be the gap for the signals to pass through. If that is not the case, we need to think about breaking up the structure of the coating so that we can get radio signals through. This is used mostly right now. We use it in vehicles, for example, trains, because a train is a metal body, and then we have those glasses on it with the metal coating, and we have zero signals, and the trains need to have repeaters. So there it's already very much established, and now we know we have the same problems in modern buildings, especially when we have an aluminium facade with glass, and we are facing the same problems again. Very often nowadays they still use repeaters, active systems, to get the signal through. In my opinion, in the future it needs to change, because we can't use more energy because of those details. Yeah. We have ways that we can allow signals to go through. It's a passive system, and it would help with the reception. And in my opinion, even more important is it would help with the energy that your phone uses. Because once your phone has no signal, what it tries to do, it just turns up the signal strength of your phone. And you sometimes feel that when you're sitting in the train, that your phone gets warm, or you're sitting on an airplane and your phone gets warm. It's because it just uses all the energy to find the next point of contact where it can send a signal to. So it's an interesting subject that we have looked into. There are solutions, but it's not established right now throughout the industry again.
One example for the solution, please.
Well, in our case, the product is called Connect, And what we are doing is we have these coatings, and in the coating we bring in a very, very fine structure. You can see it with the naked eye if you go against it and look for it.
Yeah. Do you do it
on
with a
it.
laser, or how do you do that?
There is different ways. You can do it with a laser, you can do an off-lift process. There is different efficiencies behind processes. That's how you do it. So in theory, it's very good, but it's not established on the market. People still prefer to walk through the building and find a better spot to use their phone, or they in big skyscrapers or office buildings, they're just using repeaters as a standard.
Yeah, there has been a couple of studies in that one in a different way how to do it, that one, and those one, like you mentioned, it are those most popular. We have it, those one in a previous GPD, couple of papers on that one also.
Yeah, when I can add something to that conversation that we're having right now. We created highly insulating glass units. We have condensation on the outside. We created highly insulating glass units. We get an issue with the strengths. We try to make our glasses as transparent as possible. We might have an issue with the environment because birds can't see the glass. So every development that we are doing, we might learn something new, and we need to react to this again. So this is what I believe is the glass industry is doing. We try to make things more efficient and learn, oh, there is something else that we need to take care of right now. So also with the IGUs, the recycling, we made this fairly fragile coatings because there we can achieve the better thermal insulation, but therefore the edge seal needs to be hermetically sealed. And then we start having an issue with separating the materials. So it's kind of an ongoing process. We develop something new and learn, oh, there is something that might have a negative effect.
So I mean, we have been thinking about, do we don't need new materials, or do we rather develop and refine the already existing materials? For you, the glass, you said something. Marcel, what do you think about for the facades way of facade material?
I think there's a twofold. There is maybe the need for new materials, but these will not be materials that will pop out tomorrow and we have never seen them again, but most likely materials we already know, which find their way into. We talk about electrochromic glazing, thermochromic glazing, smart materials, something like that. Materials that are combined with our products that make these a little bit more smart, let's say, adaptive. They are changing color, being able to control the energy that goes through when the circumstances or the environment changes. This is something we can see. On the other side, we see new production techniques for already known materials. Additive manufacturing, 3D printing is a topic that is very prominent. I do not foresee a very fast future in which we are able to print on demand, on location, houses entirely out of 5 different nozzles in order to create load-bearing, insulating, and transparent building parts. But we already see lots of interesting ideas in which additive manufacturing, 3D printing can outperform already existing materials, maybe by just creating mono materials that are gradient. Think about sugar. It can be very solid. It can be, if molten, become transparent, but it also can be very insulative, as for instance, these sugar spin as you get on a fair. So therefore, if you are able to manipulate glass in the same way, you are able to make a transparent window that defines itself into an insulating part. That is very interesting from my point of view, looking toward new techniques in order to produce glass. But on the other side, we can also see this with concrete. Now we have now foam concrete that merges into more load-bearing parts. That is something we haven't been able to perform by standard casting. But nowadays, maybe with the help of a robot or another technique to make these elements lays opportunities to improve these building components. At the very end, they can be shredded down to a single material that is easier to recycle.
So from that on, what about this thing? Has the way, what has to change the way we build our glass and facade products? I mean, that refers a little bit to the beginning about the circular economy, and Hannes has also started to say, look, we've got very complex products, and they create sometimes problems. What do you guys think? I'd like to hand it over to Hannes. What do you think how we should go on in developing our product further in a better way, so that they also can be used as recycling materials?
Well, it's a question which I don't think I can answer, but I can tell you a few ideas that I have there. So with all the new technologies which are emerging, because we have, let's say, nanotechnologies in the area of coatings, we have new technologies to produce sealants. Maybe there is the possibility that we have coatings which are easily detachable and we can just peel them off by hand. Maybe there is a technology where the sealant suppliers provide us with a sealant that we can, I don't know, put under certain light conditions and they peel off. Marcel, we spoke about this once before, that we put some voltage through the material and they start to peel off. So there is, I can imagine a lot, but it's not the glass industry who is driving all of that. There is a lot of those things are coming from nearby industries. I mean, coating technology was not developed by the glass industry. It was somewhere else where we needed it. And if those developments move on, we can use those advantages in our industry. So I don't know what's coming. That's why I can't answer your question, but I think there is possibilities because other industries develop and we can then adopt to those technologies.
Yeah, we've also seen that my colleagues have talked to the big players in the glass industry, and every one of them said, honestly, we don't get it. For the last 100 years, you asked for better and better and better insulating glass units. We were able to increase our production by quite far, and we were able to lower the insulation or increase the insulation in order to lower your operational costs. And now you also ask us to take all of our products back after 20 years. Come on, guys, be reasonable. We already have such a high amount of recycling glass in our own production. So yeah, but this is in principle your own waste that circulates the furnace. On the other side, we see, for instance, companies for facade cladding. We had a project with Trespa, being one of the leaders in high pressure laminate facade cladding. And they are nowadays trying to increase the amount of bio-based resins into their mixture. The fibers are already wood or paper, which is also wood-based. And for the interior material, they're already able to subsidize 50%. On the facade, they still have problems. The chemicals are not that good. In order to make a more bio-based product, they reduce quality. That's not what they want to give up onto, because they claim we are the most durable facade material. But due to the fact that these facade claddings here in the Netherlands, especially where buildings are already teared down after 15, 20 years, they say from now on, they made that claim 2 years ago on the Munich fair, that they will take back all facade cladding materials that have been sold nowadays. Means in 20 years, there will be a big stream of facade cladding coming back. They have already a couple of ideas what to do with that, but this is also a way of dealing with the problem. So therefore, it's either in the mixture or in a smart way of dealing with the issue of taking it back for recycling.
Okay. So let's head on. Time is going forward. Yoma, do you like to add a question?
Not at the moment. Anyway, I think that we get it pretty good answers. Anyway, those insulating glass and energy efficiency, of course, because I was out, I couldn't get it the connection. The
Yeah.
link
Oh, so, okay.
link didn't work, so I don't know. The circular economy is anyway interesting, but you go through that one already.
Yeah, because
Already, and how the coating affects to the circular economy. Anyway, that's a one issue also.
yeah. So then I would go on and would ask, and so what are the benefits of producing energy with buildings in integrated photovoltaics? So what do you guys think? I mean, is this a thing? We've got such big facades everywhere in the world. Even we've got the big tower blocks, skyscrapers all over. They would have PV units inside. Would it help? Would it be good? Is it reasonable? And can we manufacture and in a proper way? What is your opinion about that?
Should I start?
Marcel, go on.
Yeah, I think being able to produce energy more than we need within a building is a fantastic goal. PV panels are able to help. Think also about thermal water, for instance, heating up water, having solar collectors on top in order to produce also hot water, maybe even in combination with heat pumps or whatsoever, can also create a very efficient way of using surfaces on your building, the 4 facades and maybe the 5th to be the roof, to create as much as energy as possible. On the other side, we see often from architects, I've been facade consultant with our own office for 8 years, and often our architects doesn't like PV panels. And then we come up with a huge array of different colors and patterns, and they still don't like it. So therefore, there is also a general acceptance. I've also planned facades facing north with uninstalled PV panels because the company wanted to create a green look and a very sustainability image. Whenever people enter their building, they see that this entrance is cladded with PV panels. Either or IK, they must be very good in sustainability. And a recent development I've seen is on the facade fair here is a new frit pattern, sort of a mesh that can be printed and looks very awesome because you have all the freedoms. And they also create power. And I asked the company about the efficiency. I said, yeah, we have a reduction in our efficiency compared to a standard PV panel by about 60%. He said, what? Only 40% of energy producing is left? Yeah, but our clients doesn't buy them because they want to have PV. They buy them because it's a good looking facade cladding that also produces a little bit of energy. So
Okay.
therefore it's the turnover. So therefore aesthetics first, functionality second, and this is then an extra bonus if it can also make a little bit energy.
Okay, that's interesting. That's what you add for that.
Well, it's an interesting concept, but let's see how it works out in reality. Because if I have a PV panel with 40% efficiency compared to the normal PV panel where the efficiency is not that high, and that product is probably not the cheapest. Let's see how many
No, for sure not.
Let's see how many meters they put into the facade.
Yeah, the previous meeting, Sener was going through those transparent solar cells, and there is efficiency is below 10%, but it has been coming pretty good anyway if you compare those one, what was in the early days anyway. But it's still a long way to go. And depending, of course, the angle, how the sun shining to the facade, that's even more important in this case also.
Yeah, absolutely. There is coatings that they're using, which also gives you a certain color freedom now. And you get higher efficiencies than the ones that Marcel just mentioned right now. But in general, I'm questioning where do we use them and where do we use them sensibly. I think there is a certain competition of surfaces on a building. So every surface has a function. Right now we have the glass we can look through, we get light into the building, it blocks out rain, it blocks out noise and so on. And what are we doing with the brick wall? Do we accept that it has a certain color and again the function of keeping out wind and rain and so on? Or do we add values? / we put a PV panel on it, or we potentially put some greeneries on it, and therefore can reduce, if the watering system works, therefore can reduce potentially cooling loads. I mean, I'm sitting here in England right now. We have a heat wave in England. In the house, it's terrible because it's English building culture, and I'm living in an old English house, so it's not the best thermal performing building. But when I go outside into the garden, it's actually nice and cool, especially when you're in the shade. So I think depending on the building, we need to look on what is the right thing for the surface. Is the right thing that we hang something on it? It helps us with the cooling. It collects CO2 because plants collect CO2 and put them in the structure. Or do we want to have PV panels because they are so efficient that we actually can help with the cooling system in the house or whatever? So I think it's very much depending on where is the building and what's the concept of the building. But yes, we need them to win energy. It's clear, it's good, but is it always on the wall? I don't know. I'm not sure.
Okay, good. So time is running forward. So I would like to open the questions. So if somebody has a question, so please go ahead, raise your hand, and switch on your the microphone. So
Not
no
everybody at the same time, guys.
I don't see a hand. So maybe somebody likes to ask something.
Yeah, maybe to the battle of the surfaces. This is really interesting. We have constant discussions about how should an optimal facade look like, and I always often refer to my own PhD I did 10 years ago already, in which I developed a little software tool that helps architects and planners to decide in the very early stages of the planning, according to the location/climate zone, to find the best combination of installation and facades. And this is what we try to teach also within our university, and that's what we also see everywhere else where our colleagues teach, that we have to get a certain awareness of the location first. You don't have to deal with sun shading that much in a highly high-rise area where the buildings shade itself. So therefore, always make sure that you have a good understanding of the local conditions, and then try to make the most out of that instead of trying to fight against it. Back then, a nice anecdote, when they developed the outboard motor, you could have made everything into a boat. You didn't have to understand aquadynamics or aeronautic marine design at all. Just on an old door, you put a 5 horsepower outboard motor and you had a ship. And that's what the air conditioning system made our buildings look like. You are capable of building a glass house in the desert, because the air conditioning is able to climatize and make it comfortable in there. But you have to ask yourself, does it really work that way? Is it a smart idea? Wouldn't sailing not be the best approach in order to make sure you are able to work with the winds instead of against it? And there's a couple of clever ideas that you can apply in order to make sure your buildings do the best out of that. And the general answer is always, it depends. So therefore, you really have to be aware of finding the local resources, maybe you're able to tap onto, and then plan from that. Due to my own research, we figured out that 30% glazing ratio is already enough to have an autonomous daylight in your offices. Means everything you put above 30% glazing, which is quite okay, but not the fully transparent, highly democratic buildings we are all oozing and looking for. But if you create more glass than that, you're already introducing the sun into your building at a certain rate that it's not comfortable anymore. And you have to think about either a good, efficient exterior sunshade or other techniques to get rid of it. So therefore, you have to be smart and you have to be in a good team in order to tackle that. And there's no general answer for the best facade possible, because you have to look where you built.
Okay, but therefore I have a question as well. I mean, when we talk about you have let's say a brick wall, you have and you say, well, look, you put some PV on front of that. I personally find it's not a great idea, because either we use a brick wall or we use some facade with the PVC in it already. So, I mean, all these solar panels I see on roofs, I find it a bit silly because there are better ways of doing that. I mean, instead of putting things on top, so rather making a new construction which has it in already in a proper way. So
I think that's the question of the application in general. I would recommend, if you are building apartments, houses, row houses, whatsoever, and you want to think about applying PV panels, don't put them on the roof on top of roof tiles. Get rid of them, because a piece of glass is very, very good in keeping the rain out. And we are able to make facades and roofs out of glass, in this case PV, that already serves in all these properties. So therefore, make the entire PV panel your water guiding system, and use PV panels as your roof cladding, and not having a clay roof tile or a concrete roof tile where you put everything on top of it. On the other side, if you already have a building and you would like to upgrade it by sustainable renovation, yeah, then it may not make sense to get rid of the entire roof and then put something entirely new on that. So therefore, there's always a differentiation in between renovation and newly built projects. Focusing on the building stock, we could say 90% of everything we need is already built. So therefore, we also have to look into refurbishment as a big market.
So
If I can add something to this, because we did some studies recently on where to put PV panels, and the answer was it's actually cheaper to put it up on a brick wall.
Yeah.
Rather than using a stick system or whatever, and integrate the panels in there and then add the insulation on the back. So having just a standard brick wall, forget about the plaster, and then add your panels was the cheapest solution. But all of this can change or will change depending on legislation that we're going to get or that we're having. There's quite a big drive for kind of green parties in the last few months and years all over Europe. And I think with changing legislations, that will also change. That it might then be efficient to either have it completely installed in a new build or to add them wherever we need them in a refurbishment. But this is something where the pressure needs to come from the politics, from the government. As long as this pressure is not there and there is no extreme reason for it, the companies will continue with their concept that they're following right now to sell their products or to use their products. So yeah, it's in my opinion, it depends on what the rules are to a certain extent.
Yeah, it's also sometimes, especially for PV, for instance, you are most likely looking for the highest yield, which then on roof, for instance, on industry halls, you see slanted PV panels, which create a peak during lunchtime when the sun is the highest in order to get the most out of it. But if you would have placed them flat, maybe just a little tilt in order to get rid of the water, then you create a little dent before and after lunch that spreads a little bit, is a little bit of reduction of the overall yield, but then you can already create a lower investment in material that you use to put them up on a higher tilt. So therefore, on a facade, for instance, is also very efficient because you don't think about putting them in an angle, but they are able to get a higher yield in the morning, for instance, or after lunch, and therefore you're not adding to the peak where sometimes regions already have too much power and they don't get rid of it during lunchtime.
okay, so thank you. I think with looking at the time, I would ask one more if there are questions from the audience. So please feel free to ask. So if not, I would like to thank everybody for participating, and I also like especially thank Marcel and Hannes to be the speakers for these sessions. Thank you very much. I find this very interesting, and I also thank Jorma for attending as the co-host. So it's this talk was recorded. We will send out and let you know where you can get it if you have if you're interested in to something more, or like to send it to some of your colleagues. So I would say thank you very much to everybody and see you next time.
Okay,
Was a
thank you
pleasure.
from my side also. Thank you.
Bye, Jorma.
Thank you very
Bye-bye.
much. Was a pleasure.